Question 34 was quite tricky for a lot of people because it was difficult to see how to get started. Now, important parts, we have a discrete probability distribution, and that means that we could draw up a probability distribution table. We haven't been given one. Instead, we've got a probability function here. And we're told that x can go on, potentially up to infinity, and we have to find b. So the first thing that I would do here is, I know it's a discrete probability distribution, I would draw up a distribution table because that gives me an idea what we're working with here. So one of these things, and we've got 0, 1, 2, 3, and let's put the ... too, just to remind us it goes on forever. Now all we've got to do to find the probability of any one outcome occurring is to sub that value of x into this little recipe. So we've got b multiplied by 2/5 to the power of, well in this case 0, so that whole section will just be 1 because anything to the power of 0 is 1. So the first probability will just be b. The second one will have 2/5 to the power of 1, that's just 2/5. So we've got b multiplied by 2/5. Then we're going to have b multiplied by 2/5 squared, and b multiplied by 2/5 cubed, etc, etc, etc. So the only thing that's going to change is that that number in the index is going to go up by 1 every time. Now, as soon as you see it in a table like this, for me that's a much easier way of seeing that there's something I can do, because I know that the sum of all probabilities in any experiment must by definition be 1. So I can add up all of these, and what I'm going to find is that I've got some sort of limiting geometric series. So the next thing I would do is I would reason that if I'm adding all of these together to get 1, I could write out the terms I've got and put ... I can already see that they've all got b in them. So to me it makes sense to start by factorising it and saying I've got 1 plus 2/5 plus 2/5 squared plus 2/5 cubed plus lots of other things all the way up to 2/5 to the power of n if you like, but we can just put ... and that equals 1. Now I'm just going to save a bit of space here. On my next line I'd probably just divide both sides by b, so I'm going to be a bit cheeky and just do that to save myself a little bit of space here. Now this whole section that's on the left hand side is a geometric series, isn't it? Now what are its features? Well, its first term is 1 and its common ratio is 2/5. Now I know that this is a limiting geometric series because the r value is between -1 and 1. And when that happens, it means that each term you're adding is smaller than the one before. And so if you're adding increasingly smaller and smaller scores, there's going to be a limit that it's going to approach. And to find that limit, we say that the sum to infinity is a over 1 minus r. So I'd have this working over on the side, I think, just to show my reasoning. And I can think through here that a over 1 minus r, where a is 1 and r is 2/5, is what the whole left-hand side of my equation is equal to. So continuing on, a is 1 over 1 minus r, well 1 minus 2/5 is just 3/5, is equal to 1 over b. Now these are both 1 over something, so I think I can just safely say here b equals 3/5. So that was quite straightforward really, but maybe for some people it's just hard to know how to get started. Now it's worth 3 marks. There'd be 1 mark for coming up with something of a table here, or this some expression that shows that all of those things add to 1. Then there'd be a mark for reasoning that we've got a limiting geometric series on one side, and there'd be a mark at the last bit just for solving for b.